Okay, we're going to continue on our notes for lines and linear equations. We're going to remind ourselves what are x-intercepts and y-intercepts. So your y-intercept is where your graph crosses the y-axis. If it's crossing the y-axis, the x-coordinate is 0. So as a point, these look like 0, comma, some y value. The x-intercept is the exact opposite of that. It's where your graph crosses the x-axis. If you're on the x-axis, then your y-coordinate is 0. So these look like some x value, comma, 0. So when we want to find the intercepts of a graph, those are the ideas that we use. Anytime we want to find an intercept, we let the other value be 0. So in this example, if I want to find the x-intercept, I'm going to let y be 0 to do that. So 4x minus 3 times 0 equals 6. 4x equals 6. So x equals 3 halves as a point. That is the point 3 halves, comma, 0. Conversely, if I want to find the y-intercept, then I'm going to let x be 0. So y equals negative 2 as a point. That's the point 0, negative 2. Let's just do one more example of these that works the same way. If I'm finding the intercept, we're letting y equal 0. So 0 equals 3x minus 6. I get 6 equals 3x. X is 2, so this looks like 2, comma, 0. The y-intercept is just when x is 0, so we get y equals 3 times 0 minus 6, or just y equals negative 6. This is the one that's really easy to find when they give us that format, and we just know that this is the b value already. Okay, let's move on to linear functions as mathematical models. So you're going to have some other definition words that you need to know. The independent variable is another word for the input variable. Typically this is x, but it doesn't have to be. In word problems and other scenarios, it could be a different variable. You just have to kind of look and see. Dependent is the output, and again, typically that's y. As long as we're sticking with x and y's, your domain is the set of all of your input variables. So usually your domain is your x's. And your range is the set of all of your output variables, or y's. A function is a rule that assigns each element in the domain to exactly one element in the range. So for each x, for every element in the domain, for every x, there is exactly one y. Other ways that you may have checked this before is that it would pass the vertical line test, because anywhere you would go on the x, there would only be one y associated there. So function notation is when you just replace your y with the symbol f of x for the function of x. So don't make these harder than they are. As long as it is a function, to put it in function notation, all you do is you take that y and you replace it with f of x. It's an easy way for us to communicate with each other on paper that we are talking about a function. So anytime you see f of x or g of x or v of x or any symbol like that, then we all know we have communicated with each other that we are certainly talking about a function. So the last thing we want to do are a few application problems. One application is simple or straight line depreciation. So estimating the value of an asset as it loses value over time. A lot of times what they give you is the original price, its useful lifetime, and its scrap value. And with that information, we can set up an equation and figure out the value after any amount of years. Okay, so this example says a farmer buys a harvester for $50,000. So that would be its original price. Its useful lifetime is up to 20 years, at the end of which its scrap value is $6,000. So we want to find the equation for the value V for the harvester after T years. So here our X and our Y have changed variables, our input and output. Instead of X we have T, and instead of Y we have V, but everything else works exactly the same. Okay, so what they've given me here, kind of in, they haven't just completely said it, but what they've given us is they've given us 2 points. So at a time, so again, our points look like this. At a time of 0 years, when they first buy this harvester, it's worth $50,000. So that's 1 point. And at scrap, so at 20 years, when it's determined to be scrap, it's worth $6,000. So what we can do, it says we want to find the equation. So we're basically right where we were in that first example, where we first want to find the slope, and then we want to find the rest of the equation. So let's see, let's take 6,000 minus 50,000 over 20 minus 0. The bottom's definitely 20. That's an easy one to do. Doing this top subtraction, I'm going to get negative 44,000. Reducing that down is negative 2,200. Okay, now we want to finish writing the equation, but don't work too hard here. I could certainly go back up. I could go all back up to this method right here, and I could then do point slope, or I could do this process where I find B. But be on the lookout for points that actually just tell us B. This is B. They've given us the y-intercept, so don't work too hard here. In function form, this says the value of this after t years in time. Here's my slope, negative 2,200 times t, and I already know B. B was 50,000. So done, we found the equation. What is the rate of depreciation per year? Well, the rate is another word for the slope, so that's negative 2,200 per year. That's how much value it's losing every year. Now use this equation to find the value of the harvester after 5 years. So 5 years is a t value. This means we want to find V of 5. Okay, so if we grab a calculator or do this by hand, however, I don't do it by hand, grab a calculator. Grab a calculator and do this. This will give us negative 11,000 plus 50,000 equals, this is 39. So 39,000 is what this is worth after 5 years. Let's do one more example of a linear function application. Something very relevant would be a salesperson receiving a base salary of $35,000 and a commission of 10% of their total sales for the year. So first we want to write a linear model here for their total income based on total sales of X dollars. So again, we've got X being our input in this case. And then we want their total income. Incomes, I would be kind of a little hard to write. Let's go ahead and just call, let's just not even do this in function notation. Or let's do. We'll call this f of x. Now, there's no work really to be done on this one because I've got all the information I need to know to go straight to the formula here. We know they're going to earn $35,000 no matter what. So that is our B value. And then they earn 10% of the total sales for commission. So whatever their total sales are, X, they also get 10% of that. So I had both the M and the B given to me in here. I didn't need to calculate either one of them. That really saves down on a lot of work. And then we can jump straight into the second part of the question here. If the salesperson sells $250,000 worth of merchandise, what is her total income? So what's f of 250,000? So if we want to find 10% of 250,000, we just want to move that decimal point. Sorry for my writing there. So it looks like the total income for this year would be $60,000.